Hello everyone. Yesterday we did 30 questions and today we'll be continuing it from the question number 31. Okay. I'm Amodini and I'm a student at IIIT Sri City and I'm gonna cover most of the PYQs from the topic scalars and vectors. Okay. So let's begin with the 31st question. The question states that the maximum range of a gun of horizontal terrain is 16 kilometer. If g is equal to 10 meter per second square, then muzzle velocity of a shell must be what? So here we can see that we are using range. So range is a part of which topic? It is a part of projectile. Right? Projectile motion, we have learned about it. So it's a part of projectile. So what they are telling is R max जो है वो है v square by it's v square by g. And when is R maximum? It is when the theta is equal to 45 degree. So since the formula contains v square sine 2 theta by g, and we know that sine 2 theta of 45 degree will be sine 90 degree, and that is 1. So you'll get v square by g. So substituting it, so v square by g is equal to 16,000. And then you just take it over here. So you'll get 16 into 10 to the power of 4. So you take a square root because it is v square and we need v, right? So taking the square root, you'll get 400 meter per second. So that is option C. Okay, it was a pretty easy question, right? Okay, let's move on to the next question. The next question states that two bodies of same mass are projected with the same velocity at an angle 30 degree and 60 degree respectively. The ratio of their horizontal ranges will be what? So we've covered this kind of question before. So we can see that just 60 degree and 30 degree are there. They both are complementary. Okay. What does complementary mean? Complementary angles are theta, comma 90 minus theta. So in place of 0, okay? Yeah. In place of theta, if I substitute 60, I'll get 90 minus 60, that is 30. If I substitute 30, it will be 90 minus 30, that'll be 60. So therefore, what we can say is whenever they are complementary, our ranges will be always equal. So remembering that concept, you'll get it as 1:1, right? So it's the same thing. Horizontal range is same when angle of projection is theta or 90 minus theta, right? Okay, let's move on to the next question. The next question states that a particle is moving such that its position coordinate x, y are 2 meter, 3 meter at time t is equal to 0, 6 meter, 7 meter at time t is equal to 2 seconds, and then 13 meter, 14 meter at time t is equal to 5 seconds. So what is the average velocity vector? So here we'll be calculating average velocity. If we trace back to average velocity, we have learned in the chapter motion that average velocity is the change in displacement by the change in time taken, right? So I can write it as delta r. Here r is a vector because it's a displacement, right? And then delta t, and time is a scalar quantity, so I will not put up an arrow. So here we can see that this is initial, this is final. So what I'll do is subtract these two, 13 minus 2 and then 14 minus 3, and then divided by 5 seconds, right? Totally 5 seconds. So doing that, you'll get, here you'll get 11, and then here you'll get again 11. So what we can see that usually what we do is we just have one value for velocity, like in I cap or j cap direction, but there are like two values, right? Here we have this is in j cap direction and this is in I cap direction. So therefore you'll have the answer as 11 by 5 I cap plus j cap, right? Okay. So the next question is, the speed of a swimmer in still water is 20 meter per second. The speed of river water is 10 meter per second and is flowing due east. If he's standing on the south bank, so he's standing over here, the river direction is in this direction. and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north. So this is our north, right? So with respect to this, what angle should he make is the question, right? So what is the concept being used here? This is the swimmer river problem, right? We have swimmer river problem, rain man problem. So these are a few problems that are classic problems. So these concepts, once you like practice it twice or thrice, you'll get it. So the more questions you solve on it, the more stronger you get in it. Okay. So you can see that this was asked quite recently. So you guys should focus on this. Okay. So here, how do we do this? So here you can see the diagram. This is the angle that we need to calculate. East is the direction by which it's moving, right? So what we can write is VSG. So the swimmer relative velocity is nothing but VSR plus VRG, right? And similarly, sine theta. Sine theta, I can write it as, what do we know? VRG by VSG, because sine theta is perpendicular by hypotenuse, right? So therefore, this is the perpendicular, this is the hypotenuse, right? So you'll get it as VRG by VSR, right? So here you'll get it as 10 by 20. 10 because it was the river velocity, and this was the swimmer's velocity, right? So therefore, you'll get it as half. And when is sine theta half? Whenever the theta is 30 degree. So we can say that he has to move 30-degree west for him to cover it in shortest path, right? Okay, let's move to the next question. The next question is, a particle moves so that its position vector is given by r is equal to cos omega tx plus sine omega t y, where omega is a constant. Which of the following is true? So the options are velocity and acceleration are both perpendicular, velocity and acceleration. So here you can see that our options revolve around velocity and acceleration. So what is the smart thing we could do is quickly calculate the velocity and acceleration. So we know r over here. So tracing back to motion, we'll differentiate it, okay? So here we can see, after differentiating, you'll get this as your velocity and this as your acceleration. To see if they are perpendicular or they are on the same plane or something, the best method we could use is dot product, right? So we'll use dot product, and here we can see that r dot v is equal to 0. Why? Just multiply it cos omega t and then sine omega t. You'll get it as minus omega sine omega t cos omega t, and then here plus sine omega t cos omega t. So they'll get cancelled out. So you'll get 0. So therefore, we have an option that velocity is perpendicular to r and acceleration is directed towards the origin. So here we all, so this option we have left with this two options. These two are ruled out, right? So we have to calculate, we have to check if it is towards or away from the origin. And how do we do that? Here we can see that it is acceleration is minus omega square r. If our acceleration would be omega square r, then it would be away from the origin, but it's not, okay? So therefore, we get the answer as option C. So let's move on to the next question. The next question states that a ship is moving westwards with a speed of, so it's moving westwards, okay? Ship is moving westwards with 10 kilometer per hour, and a ship B, so this is, and a ship B 100 kilometers south of A. So let's say this is A, and 100 kilometers south of A, there is a ship B. and there is 100 kilometers gap, okay, is moving northwards. So this is moving in this direction with a speed of 10 kmph. Okay, the time after which the distance between them becomes the shortest. So this is also similar to the swimmers and river problem. Okay, so again the concept is swimmer river. Lekin instead of swimmer we have a ship over here, two ships basically. Okay, so let's calculate this. So here they are telling that let t be the time passed and x be the distance covered by the two ships after the distance between them became shortest. Okay, so here we can see that it has traveled x distance, right, already, and then this is 100 minus x, right, because total is 100, so it has traveled 6, so the distance between them is 100 minus x. Okay, so yeah, yeah, so we can see that distance between the ship is given by 100 minus x square plus x square. How did we do that? We did that using Pythagoras theorem, right? Here we can see that. Yeah. So here we can see that this is, so we need to find this. This is the right angle triangle. So 100 minus x square, this x square. So finding s would be using Pythagoras theorem, right? Okay. But there is a condition. We needed the shortest path. So that means that s should be minimum, right? For that, what we'll do is we'll differentiate it. So we'll do ds by dt should be equal to 0. That means it should be minimum. So doing so, you'll get it as, you'll get the equation over here basically, right? So solving the equation, you'll get x is equal to 50 meter. So after both the ships have covered 50 meter, the distance between them became shortest. So the time taken would be t is equal to x by 10. So x is over here is 50. So 50 by 10. So that is 5 hours. And that is option A. Okay. Let's move on to the next question. The next question states that the position vector of a particle r as a function of the time is given by r is equal to 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap, where r is in meter, t is in seconds, and I cap j cap denote unit vectors along x and y directions. Which of the following statements is wrong for the motion of the particle? So again, we are covering the concept motion. Okay. So here, what is the question? So here in the options, if you see, there is acceleration we need to check, velocity we need to check, and the path. Okay. So these are the things we need to check to get our answers. So what would we do? So basically, first we would calculate. We know that x is equal to 4 sine 2 pi t. Nothing but r has been split into x plus y, x I cap plus y j cap. Okay. So here, this is how they've done it. Okay. So squaring and adding the equation, you'll get it as x square plus y square is equal to 4 square. So that means that I can tell that my r is equal to 4. Yes or no? We can tell that, right? Because r is equal to nothing but x plus y. So therefore, r is equal to 4. You got that. Motion of the particle is in circular motion because the equation you got it as r x square plus y square is equal to 4 square, and this is the equation of a circle. Acceleration vector is along minus r, and its magnitude is equal to v square by r. So therefore, velocity of particle we can calculate as v omega r, and here our omega is 2 pi, right? So 2 pi into t. T is equal to 4 seconds. We've got it. Sorry, t is equal to I mean, r is equal to 4. So I've got it. So it is 8 pi. And here, if we see, our option B is correct. Magnitude of the velocity of particle is 8 meter per second. Okay, let's move on to the next question. A particle moves in a circle of radius 5 centimeter with constant speed and time period is equal to 0.2 pi second. The acceleration of the particle is, what is the concept here? Circular motion. So what they have told us, they have given us the radius and that is equal to 5 centimeter. And the time period, okay, big T is basically 0.2 pi. And the speed is constant. So we need to calculate the acceleration. So here the acceleration in circular motion would be centripetal acceleration, and that the formula is omega square r. And here our omega is basically 2 pi by t, right? So that is what we'll be substituting. Yeah. So here also you can see that I've given 2 pi by t and t is 0.2 pi. And then pi gets cancelled and then you'll be left with 5 meter per second square. Right? Makes sense? Okay. So our answer would be 5 meter per second square. One thing that we need to remember is it is given in centimeters. Okay. At times the question could be, options could be confusing. There could be 0.5 or 0.05. So if we took or 500 or 50, the options could be something like this. So usually what we do is we neglect the units and that could cause a catastrophe. So let's not focus on the units too. Okay. So moving to the next question, the question is, a car runs at a constant speed on a circular track of radius 100 meter, taking 62.8 seconds in every circular loop. The average velocity and average speed for each circular loop respectively is 0, 10, 10, 10, 10, 0, 0, 0. Okay. So here again, circular motion. That is the concept. And what are they telling? They need average velocity and average speed. Okay. Okay. So how do we do it for each circular loop respectively? Here we have 100 meter and then 62.8, right? Okay. So we do it by calculating the values using direct formula. So using the direct formula, you'll first tell what is the distance covered. This is nothing but the circumference, right? So therefore, you'll get it as 628 meter, and then average speed would be 628 by 62.8. So 10 meter per second. Why is the displacement zero? Average velocity depends on displacement, right? So this is a circle, right? We say one circular loop is done when you start from here and then you complete over here. But what does displacement mean? Displacement means change in position of the body. But after covering this, did the body's position change? No. So therefore, our displacement will be zero. And we need to also shed the light that our displacement is a vector quantity and it is zero. So therefore, the option would be 10, 0. And average velocity is 0. So yeah, here what is the common mistake that we could do? We could select 10, 0, thinking that first it's average speed and then velocity. So let's not make such silly mistakes, right? Okay. Let's move on to the next question. So the next question is, two boys are standing at the ends A and B of a ground where AB is equal to A. The boy at B starts running in a direction perpendicular to AB with velocity v1. The boy at A starts running simultaneously with velocity v and catches the other boy in time t, where t is. Okay, so this seems very confusing, but it's not really. Okay, so there are two boys, okay, A and B. So they are both are here. So they're telling AB distance is basically A. Okay. Let's just make it small a or something. It's fine. Yeah. And what they're telling is the boy at B starts running in perpendicular to, so he starts running over this direction. Okay. So this is V1. The boy at A starts running simultaneously with velocity V. Okay. And catches the other boy. If he has to catch the other boy, he can't run like this and this. So he will run in this direction to catch him. So this is the velocity V and the time T. Okay. So what we'll do is we'll call this point C. So here we can tell that AC is equal to VT. Why did we tell that? We have been given the time is T and we know that distance is equal to speed into time. So yeah, so you'll just multiply displacement into time. So AC is equal to, this is equal to VT and then BC is equal to V1T. Now just calculate it. We know this is the hypotenuse. Apply Pythagoras theorem and then you'll get it. And then finally you'll get it like T is equal to root of A by V square minus V1 square. Okay, so that will be our option, root of A by, right? Root of A by V square. Here we can see that A and then there is a root. What is the silly mistake we could make here? We might select this because we got something like this. But no, there's a plus sign. So we have to check it over here and that's option D. Though it has been written as A square ka root. So we can still simplify it as this, whatever we got. Okay. So with this, we've got our answer. So moving on to the next question. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of the acceleration of the stone? Okay, again, this is circular motion. Okay, the concept is circular motion. So here we've been given, we have to find out the acceleration and the direction. Okay, so how do we do that? We know that AR is equal to omega square R, right? This is the formula, direct formula. And then tangential acceleration would be dv by dt. But it is equal to 0. Why? Because here we've been given it is constant speed, right? So therefore dv by dt is 0. Constant. Right. And AR, you can just substitute the values. This as omega square is nothing but the revolutions made and everything. So you'll put it in as 2 pi n square r. So you'll get it and then you simplify it and then you'll get this. Why is it 22 by 44? Basically 22 revolutions are done out of 44, okay? In 44 seconds. So therefore you'll be taking it as that. Okay, so again, A net would be pi square meter per second and direction would be along the radius towards the center. Okay, sure. If the force acting on a particle is always perpendicular to the velocity of the particle, then the path of the particle is a circle. Okay, the centripetal force is always perpendicular to the velocity of the particle. Okay, so centripetal force always acts in this direction. Okay, whenever the velocity is in this direction, so always perpendicular. Okay, so with this we got the option A as our answer. Okay, moving on to the next question. The circular motion of a particle with constant speed is, okay, so we have circular motion concept again and the constant speed. We just noticed it that it has to be periodic, but they are not in SHM. So what exactly do you mean by SHM? SHM is nothing but oscillation. Did you see that there is any oscillation going on? Oscillation, you can just take an example of pendulum. Okay. So the to and fro motion, okay. This is called oscillation, and this is basically SHM. So, is there an SHM in a circular motion? No. So, therefore, we rule out, this out. But okay, we can not rule this out and this out, okay? Because we do agree that there is no a simple harmonic motion. But is it periodic? So basically, what happens in a circular motion of a particle with constant speed, particle repeats its motion. So basically, so let's say it's at this point. It travels all this way, and then again after one loop, it again repeats its motion, right? So therefore, at a regular time interval, there is motion repeated. So it is periodic. Okay. So with that, we get our answer. Okay. Let's move on to the next question. A stone is tied to a string of length L and is whirled in a vertical circle with the other end of the string as the center. At a certain instant of time, the stone is at its lowest position and has a speed of u. The magnitude of the change in velocity as it reaches a position where the string is horizontal would be what? Okay, so this is a mix of circular motion and string whirling, okay, and string concept. So what they want to know is, so there is this at the lowest point, this is the velocity u, and then here over here it's this. So we need to calculate. So wmg is equal to, this is nothing but work. Okay, here we'll be using work energy, okay, concept. So we can write that minus mgl is equal to half mv square minus half mu square, right? Yeah. And then similarly, solving this, you'll get this, okay? But then u is equal to ui cap, and v minus u will be this, because this is in I cap and this is in j cap. We can see that this is in this direction, right? So yeah, so we got it as v minus u is equal to this. So magnitude would be root of this thing. So therefore, you'll get it as root 2 u square minus gl, right? So this would be option B. Okay, let's move on to the next question. So they're telling that vectors a comma b and c are such that a dot b is equal to 0 and a dot c is equal to 0. Then the vector a is parallel to what? So directly we can do that here again, dot product concept. And then orthogonality is here. Orthogonality is nothing but perpendicular, right? So they're telling a dot b is equal to 0. That means that either a or b is equal to 0, magnitude is 0, or they both are perpendicular. So here, let's just say I assume that A is perpendicular to B. Similarly, I'll tell that if I take it as A is perpendicular to C, then what will happen? I can rather take a vector triple product. So what is vector triple product? I'll just take this option up or this or any option, okay? And then cross product it. Because we'll be using sign over here, right? And we know that if this, the resultant would be perpendicular to this, right? So B cross C is perpendicular to A, and A cross A would be something like that, right? So here we basically calculate the vector triple product. So this is how you'll write it. And then you can further write it as B into A dot C minus C into A dot B. Okay. And that'll be equal to 0. And we can tell that A is parallel to B cross C. So that is, our option is D. A particle moves along a circle of radius 20 by pi meter with constant tangential acceleration. So basically, Vt is constant. Okay. If the velocity of the particle is 80 meter per second, at the end of the second revolution after motion has begun, the tangential acceleration is what? Okay. So this is again circular motion. And here we are not focusing on the velocity which is acting towards the center. We're focusing on the tangential acceleration, velocity. And we need to find the tangential acceleration. So direct formula application. So here we can say that Vj is basically, it'll always be in this direction, right? It's always perpendicular, and this is in J direction right now, let's just say. Okay. So Vj is equal to 80 meter per second. So omega would be equal to 80 pi by 2 theta. So that is, 8 theta pi by 2 theta. That is equal to 4 pi. And then similarly, theta is equal to 2 r by rn. So that is 4 pi radian. So you just apply the equation. So this is the equations we have, right? So this is nothing but Newton's equation, right? But in the form of circular motion. So just apply it and then you'll get it as alpha. You'll get alpha. And we know that tangential acceleration is AT is equal to alpha r. So just substitute the values and then you'll get the answer. And our correct answer is B. Okay. Let's move on to the next question. Okay, so the next question states that two particles of mass m and m are moving in a circle of radii r and r. Okay. If their time periods are same, so they are telling masses are same, radius is same, and also time period is also same. These three are same. What will be the ratio of their linear velocities? Directly, we know that V is equal to R omega. Okay. Here we have it as, okay, I think there is a print mistake. This has to be small m and this has to be small r, right? Yeah. So with this, what I'll tell is V1 is equal to omega R1. R1 is basically here R. Okay. V2 is equal to omega R2. Here our omega would be same because time period is same. So therefore V1 by V2 will be equal to R1 by R2 and that will be equal to R by R. So this is this. You have to observe this thing that mass wouldn't play a role because we are just focusing on the time periods, linear velocity and everything. And if there was force or something, then mass would have played a role. But it is not related to it. So it was barely motion related. The concept over here was circular motion. Yeah. Let's move on to the next question. The next question states that a small sphere is attached to a cord and rotates in a vertical circle about a point O. Okay. So there is a point O, and then, yeah, a small sphere is attached to a cord and rotates in a vertical circle about point O. If the average speed of the sphere is increased, the cord is most likely to break at the orientation when the mass is at which point? Okay. So here you will be somewhat focusing on tension. The concepts would be tension, force, and string related. Okay. Okay. So here we can see that there is this is the tension at this point. Tension will be acting inwards. This will be mg and this is the theta that is being made. So using vertically opposite, you will get it as, not vertically opposite, in the parallel lines, that one, it would be theta. So here you'll get it as, this is mg, so this will be mg cos theta and this will be mg sin theta, right? So we can write it as T minus mg cos theta is equal to mv square by L. Okay, therefore I can write T is equal to mg cos theta plus mv square by L. So we know that tension is maximum when cos theta is equal to +1, right? And velocity also should be maximum. Okay, this should be equal to 1 and this should be maximum. And that is, both conditions are satisfied at the lowest point. Here, we know that cos theta is equal to 1, matlab theta is equal to 0. And velocity is also maximum because you have just given a push over here. So therefore, the answer would be point B. And this would be our answer. Okay. Let's move on to the next question. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 kilometer. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 kilometer along the shortest possible path in 15 minutes. The velocity of the river water is 5 kilometers. Is what in kilometer per hour we need to find out. So this we can see that it has come in 2 years. Okay. And what is the concept being used? Again, boat river or swimmer river. Again, similar concept. Okay. Right. So here we can see that this is the river flow and this is 4 km per hour and 5 km per hour. So we need to find the speed along the shortest path, and that will be equal to 1 by 15 by 60. Why is it taken 15 by 60? Because 15 minutes, and then this has to be at in kilometer per hour. So that will be equal to 4 kilometer per hour. And speed of river is what? V is equal to, here we need to find this, and again apply Pythagoras theorem, and then you'll get as 3 km per hour. Okay, and that is option A. Here again, this was in minutes, so focus on it. No silly mistakes allowed on this. Okay. A stone tied with a string is rotated in a vertical circle. The minimum speed with which the string has to be rotated. Option A is independent of mass, is independent of the length of the string, decreases with increasing mass of this thing, decreases with. Okay. So here what do we do is, we know that minimum speed with which the string is rotating in a vertical circle would be, vertical circle is basically V will be equal to root of GR. Okay. So therefore, we have no mass quantity over here. So therefore, it is independent of the mass of the stone. Right? Okay. Moving on to the next question. A person swims in a river aiming to reach exactly opposite point on the bank of a river. His speed of swimming is 0.5 meter per second at an angle 120 degree with the direction of flow of water. The speed of the water in stream is, again, this is a swimmer river problem. I have told you guys that swimmer river problem, Rain Man problems, these are really, really, really important. Okay. This could fetch you marks if you understand it really well. Okay. Okay. Here you can see that. So this is the starting point and this is the reaching point. This is 30 degree. Okay. So what we'll say is V man, okay, is equal to 0.5 meter per second. And here we can write it as sine 30 degree. This is Vm, you can see here. And this is Vw. Okay. So Vm is basically what? Vm sine 30, VW is Vm sine 30 degree, okay? Sine 30 degree. And I can write it as Vm is equal to VW. VW is equal to Vm by 2. And that will be 0.5 by 2. And that is 0.25 meter per second. Okay. And that is our option C. Okay. Let's move on to the next question. A ball of mass 0.25 kg attached to the end of a string of length 1.96 meter is moving in a horizontal circle. The string will break if the tension is more than 25 Newton. What is the maximum speed with which the ball can be moved? Okay. So here again, this is a string problem with tension concept used. Okay. So here again, we'll be doing it as T is equal to mv square by r because it is being whirled, right? And we can write that velocity is equal to tr by m. So similarly, you can calculate it and then substituting the values, you'll get 14 meters per second. In the horizontal circular motion of the ball, tension in the string is balanced by the centrifugal force. Okay. So there is a centrifugal force also, mv square by L. And hence the maximum tension in the string will be for the maximum speed of the ball. Okay. Okay, and that is our option A. Okay, moving on to the next question. The next question is, a body is whirled in a horizontal circle of radius 20 centimeter. It has an angular velocity of 10 radian per second. What is its linear velocity at any point on the circular path? So we need to, this is again related to circular motion. So it's given that radius is 20 centimeters. So convert it into meters, and then the angular velocity is 10 radian per second. So we know that linear velocity is equal to radius into angular speed. So you just substitute and then you'll get the answer as 2 meter per second. And that is the answer. Again, silly mistake point would be not checking the units. Okay. Moving on to the next question. It is, when a body moves with a constant speed along a circle, its velocity remains constant, no force acts on it, no work is done on it, no acceleration is produced. So the first option A is wrong because there is velocity changes. Okay. Speed might remain constant but not velocity. Okay. Option B, no force acts on it. That's wrong because there is centripetal force. Okay. So that is wrong. Option C, no work is done on it. So basically, this is the correct answer. No acceleration is produced. That is also wrong, right? Because we have tangential acceleration, centripetal acceleration, and everything. So this has to be the correct answer. But what would be the explanation for this? So in circular motion, what happens is the force acts along the radius. Okay. So what happens is the displacement becomes 0. Okay. So theta is equal to 90 degree. So the work done would be F dot S, and that would be equal to Fs cos 90, and that will be equal to 0, right? Yeah. Okay. So moving on to the next question again. A boat is sent across a river with a velocity of 8 km per hour. If the resultant velocity of boat is 10 km per hour, then the velocity of the river is what? Okay. So here again, this is a boat river or a swimmer river problem. So directly I'll write this as VR is equal to VR square minus VB square. So just substitute the values and you'll get it as 10 square minus 8 square, and that is equal to 6 kilometer per hour. Yeah. Okay. Again, the next question. A and B are two vectors and theta is the angle between them. If A cross B is equal to root 3 of A dot B, what will be the value of theta? Okay, so here the concept being used is dot product and cross product. So clearly it is a vector question. So we'll write this A cross B is nothing but AB sine theta. And similarly, A dot B is nothing but root 3 AB cos theta, right? AB gets cancelled, and tan theta, sine theta by cos theta, just bring it over here. It will be equal to root 3. And when is tan theta root 3? When theta is equal to 60 degree. And here we got our answer. Yeah. Okay, moving on to the next question. The next question states that an electric fan has blades of length 30 centimeter measured from the axis of rotation. If the fan is rotating at 120 rpm, the acceleration of a point on the tip of the blade is what? This is again related to circular motion. So here centripetal acceleration will be calculating basically. So just applying the formula, centripetal acceleration is equal to omega square r. And then here we know that we can write this as 4 pi square v square. Basically, omega is what? 2 pi v, right? So squaring it, you'll get this, okay? And then substitute the values and you'll get 23.7 meter per second. And that is our option C. Okay, moving on to the next question. This is again a vector question. So what they're telling is, if a vector 2i cap plus 3j cap plus 8k cap is perpendicular to the vector this, then the value of A is perpendicular. Let's just directly use dot product. So we know that dot product when it's perpendicular, it is 0. So it'll be what? 8 minus 12 plus 8a. That will be equal to 0. So you'll just get it as A is equal to minus 4 by 8, and that is equal to minus half. So option B would be our answer. Yes? Yeah. Okay. The next question. If the angle between A and B is theta, the value of the product B cross A dot A is equal to what? So basically what they're telling is, let's take this as C. Okay. So we know that C will be perpendicular to B cross A. C will be perpendicular to B cross A and A. So let's just take it as C is in this direction. And similarly A. So it's perpendicular. And this is B. And we know that B and A has an angle theta between them. So what I can tell is C dot A, okay? Yeah. This I have taken it as C dot A. So here we can write it as CA cos theta. That is again CA cos 90 degree would be equal to 0. So basically what we tell here is that dot product of any two perpendicular vectors is 0, right? Yeah. Moving on to the next question. So this is our final question. The final question is, if A cross B is equal to root 3 A dot B, then the value of A plus B is what? We recently just calculated this. A cross B is AB sine theta, right? And A dot B is AB cos theta. Okay. So since they are equal, we had got to know that tan theta was what? It was root 3, and that means theta was 60 degree. So we know that the resultant formula, whenever you add, you will use the formula here, this one, right? A square plus B square plus 2AB 60 degree. So you will get it as A square plus B square plus AB, right? So that is option B, right? So with this, we have covered all the question or most of the PYQs, and so let's just have a recap of what was the concepts we covered today. So we had maximum of circular motion concepts, okay, and then we had swimmer, river. There were varied problems, like there were ships, there was boat and everything. What is another concept that you could try is Rain Man problem. And then we also had a few questions on strings, wherein we calculated tension. We even used work. And then finally, vectors, and that could be dot product, scalar. We also covered projectile motion, wherein we spoke about the ranges a lot. Okay, so these were the vast concepts that we covered. So what you could do is go back, go through the video, solve these questions on your own, and then focus on these concepts more, because when it comes to scalars and vectors, these are the varied patterns that they have asked till now. So you could focus more on swimmer river problem, because most of the students find that hard. So you could practice more on that. And then strings, tension, and work. So that is a part of the force concept. And then vectors, you could focus more on dot product and cross product. And then projectile motion, their equations and everything. Just revise them and you will be good to go. So with this, I'll be wrapping up this session. Thank you so much, everyone.